What happens when the universe itself is dying? Could life survive in a universe without stars, heat, or energy? It's a question that might sound impossible, but in the far reaches of time, this could be the reality we face. In today's video, we'll explore how life might endure, even in the most extreme stages of the universe's demise. What happens when stars burn out, when the cosmos grows dark and cold? Can life adapt, survive, and even thrive in these unimaginable conditions? Stick around to find out. Have you ever looked up at the night sky and wondered what the future holds for the universe? We're used to thinking about life as something that thrives in the here and now. But what happens when that universe begins to unravel, when stars die and galaxies drift apart? What happens when there's no light, no warmth, and no energy left to sustain life as we know it? We're talking about the far future, billions of years from now, when the universe could be a cold, lifeless expanse. How do we, or any form of life, survive such a cosmic death sentence? Imagine standing outside, gazing up, and seeing no stars, just endless darkness. You're left with nothing but the vast, cold emptiness of space stretching out forever. The universe is no longer the vibrant place full of stars and galaxies. Instead, it's become a desolate, frozen void. But even in this emptiness, could there still be hope for life? Could something, anything, survive the end of everything? Let's take a journey into the unimaginable and explore the strange, even shocking possibilities for how life might endure even after the universe has died. Today, we're diving into the most mind-bending possibilities for how life could survive in a universe heading toward its inevitable end. First, we'll explore the concept of heat death, where everything cools and energy dissipates. An idea that suggests life could only continue in the faintest, most desperate forms. Next, we'll look at black hole farming, where advanced civilizations could extract energy from black holes to survive in the final dark ages. Then we'll venture into the strange realm of quantum immortality, exploring the wild theory that consciousness could live on in a parallel universe long after our own has expired. Finally, we'll explore rogue planets, drifting through the void, and the possibility of life finding refuge in these starless worlds. Each of these theories gives us a glimpse into how life might hold on, even when the universe itself is dying. The concept of the heat death of the universe might sound like science fiction, but it's actually a real scientific theory. As the universe expands, it will gradually cool down and stars will burn out. Over a mind-boggling timescale, galaxies will drift apart, and eventually all the energy that powers everything we know, stars, planets, even life itself, will be gone. In a universe without energy, life as we know it simply couldn't survive. The heat death is the ultimate cold, dark fate of everything. Think of the heat death like the slow cooling of a fire. At first, the flame burns bright, full of warmth and energy. But as the fuel burns away, the fire fades until all that's left is ash. In the universe's case, this process will take billions upon billions of years. Over time, the energy will run out, and the once active universe will become a frozen wasteland, with no usable energy remaining. Even in a universe heading toward heat death, there may still be a surprising source of energy: black holes. These cosmic giants might be key to the survival of life in the far future. Through a process called Hawking radiation, black holes slowly emit energy over incredibly long periods of time, potentially providing the last energy source for any surviving civilizations. While it might sound like something out of science fiction, the idea of black hole farming is rooted in real scientific theory. Imagine a highly advanced civilization that has figured out how to harvest the energy from a black hole. They would do this by tapping into the Hawking radiation that leaks from the black hole's event horizon. It's a delicate process, taking energy from the black hole without falling into it, but it could offer enough power to sustain life for an incredibly long time. In this far future scenario, civilizations might build entire systems around black holes, using their slow decay as a lifeline. Now let's venture into one of the more mind-bending theories: quantum immortality. This theory suggests that consciousness might not be bound by the physical decay of the universe. Instead, it could persist through the bizarre mechanics of quantum physics. According to some interpretations of quantum mechanics, every time a decision is made, the universe splits into different branches, creating a new reality where each possible outcome exists. This idea leads to the question: could our consciousness jump between these realities, surviving long after the death of our universe? Think about it like this. Let's say the universe we know ends, but in another branch of reality you still exist, continuing to experience the universe. In theory, if your consciousness is tied to these quantum fluctuations, you could continue to exist in parallel realities. This doesn't mean your physical body would survive, but your consciousness might find a way to persist, jumping between universes and potentially surviving the death of our own. Now, let's shift our focus to an entirely different possibility: rogue planets. These are planets that aren't bound to any star. They drift freely through the vast emptiness of space, far from the warmth and light of suns. While this may sound like a cold, lifeless existence, rogue planets could actually provide a refuge for life in the distant future. With no stars to sustain them, these planets would rely on alternative sources of energy, like geothermal heat from their cores, to survive. Imagine a planet floating in the deep, cold void between galaxies, completely isolated from any star. On the surface, temperatures might be near absolute zero, but deep beneath the surface, the planet's core could still be generating heat. This internal warmth could potentially support life, even in the most extreme conditions. Life forms on rogue planets might evolve to rely on this geothermal energy, adapting to the darkness and cold as they thrive in isolation. As if surviving the heat death and the isolation of rogue planets weren't enough, there's one more mysterious force that might hold the key to life's future: dark energy. This enigmatic force is causing the universe to expand at an accelerating rate, pushing galaxies further apart. While we don't fully understand dark energy yet, some scientists believe that it could play a role in sustaining life as the universe grows increasingly cold and empty. Could dark energy be manipulated or harnessed to create new ways of supporting life? Or could it provide a cosmic solution to the universe's inevitable end? Picture this: if dark energy can be understood and controlled, it could potentially be used to reverse or slow down the expansion of the universe, creating pockets of space where life could be sustained. In this scenario, advanced civilizations could tap into dark energy to manipulate the very fabric of space-time itself, creating safe zones where life could endure even as the rest of the universe fades into nothingness. As the universe ages, stars will burn out and eventually cease to exist. The once vibrant cosmos will become a dark, empty place. But could life still thrive in this starless universe? The answer might surprise you. Even without stars, life could find new ways to adapt and evolve. Instead of relying on the energy of stars, organisms could develop unique biologies that tap into alternative energy sources, like radiation or even the remnants of dead stars. Imagine life forms that don't need sunlight to survive. They might feed on the faint heat from decaying stars or the radiation from black holes. These life forms could be microscopic, living in the coldest corners of the universe, perhaps existing in a form we can barely imagine. Just as extremophiles on Earth survive in the most hostile environments, like deep ocean vents or volcanic craters, future life might evolve to survive in the desolate, dark universe after all stars have died. We've explored some wild possibilities today: black hole farming, quantum immortality, rogue planets, and even dark energy as a potential lifeline. It's incredible to think that in the distant future, when the universe has reached its end, life might still find a way to survive, adapting in ways we can hardly imagine. But why does it matter? Understanding these concepts not only deepens our understanding of the universe but also inspires us to think about life in new, unexpected ways. While we may not be around to witness the end of the universe, the very idea of life enduring through the impossible shows us just how resilient existence can be. No matter the challenge, life has a way of adapting. The universe, with all its mysteries and dangers, is an incredible place. The journey to understand it, to explore its future and the survival of life within it, is a reminder that knowledge is power. And who knows? Perhaps our future descendants or even entirely new forms of life will carry the torch of existence into the farthest reaches of time. If you enjoyed diving into these mind-blowing theories with us, and you want to keep exploring the mysteries of the universe, make sure to hit that like button, subscribe to the channel, and comment below with your thoughts. What do you think? Could life survive the end of the universe? Are there any theories we didn't cover that you'd like to hear about in future videos? We'd love to hear your ideas. The journey of exploring the universe, its beginnings, its mysteries, and even its end, is one that will never truly end. The cosmos is vast, beautiful, and full of secrets waiting to be discovered. Whether it's through science, imagination, or curiosity, we will continue to search for answers, no matter how far they may take us. So remember, the universe is amazing and our quest for knowledge is just beginning.